Hello, welcome back to 13.4 Inverses of Trigonometric Functions. In the previous video, we talked about if you know the ratio, you can figure out what the angle is. So for example, again, if you know that you have a right triangle or any angle of rotation where you can figure out the reference angle, but if you know you've got, say for example, opposite over hypotenuse, which that's how I get the sine function. If the opposite over hypotenuse is 1/2, I should have 30 degrees. But we also talked about that gives you, okay, that's the reference angle, which gives you the sine for every angle that is coterminal. So if I go backwards and say, all right, what angle am I going to get if I know the sine is 1/2? It's every angle that's coterminal with 30 degrees and every angle that's coterminal with 150 degrees because I got 1/2 over here. That's confusing. So what we need to do, what we need to develop is a way of saying which of those do I want if I want just one. To make it into a function, the inverse function is going to be a function. So that means that if you put a ratio in, you're going to get one and only one angle back instead of the infinite number that we talked about in the previous video. These are called the inverse sine functions. And there's a couple things I want to point out. I know that this table looks a little confusing. There's a couple things I want to point out. We're calling this, or we, Dr. Berger, the guy who wrote the book, he's calling these inverse sine functions, he's naming them with capital letters. So you got capital S, capital C, capital T. Okay, that's cool. I've never seen that before in any other book. There's nothing wrong with it. I like what he's doing. It's a way to distinguish it. But to be honest, you're probably not going to see this much further. This is just a graphing calculator which has sine, cosine, tangent on it. Hopefully you can see it. And notice that Texas Instruments, when they printed the buttons here, actually all the buttons, they're using capitals for everything. Okay, so that's capital S, capital I, capital N. Same thing with COS and TAN. So this is not going to be something that's going to be consistent while you go through mathematics. As a matter of fact, I always think that like if you end up in like a calculus class in college and use like capital letters, your professor's probably going to look at you kind of funny and go, why'd you do that? All right, and just blame it on Dr. Berger. Don't blame it on me. To be honest, usually when we do what the what we did in the previous video, I'll show you this one. This is usually just with lowercase letters is what we what I'm kind of used to. However, another method that is pretty popular, and you may hear this, is calling it the inverse sine. We call it the arc sine, ARCSIN. And of course there's the arc cosine and the arc tangent. This shows up in different places, and probably, in my experience, is probably like an older way of saying like what the inverse sine function, inverse cosine functions are. But it does pop up in places, and I could be wrong because I tried to look it up, but it's pretty old. There's a programming language called Fortran. Look it up, Fortran. Some people still use it, but there's been some modifications. I had to learn it as a freshman in college because it was an engineering programming language. And if I recall, like I said, I tried to look this up, but I don't know, maybe I didn't do the right Google search or something. But if I recall, the code for finding the inverse sine, cosine, tangent functions was actually arc sine, arc cosine, arc tangent. The reason why I remember that is because to get pi, you multiply 4 times arc tangent of 1, and that comes from the unit circle. So if you need to use pi as a constant in your program, since tangent of pi over 4 equals 1, then dividing by 4, the opposite is to multiply by 4. So you multiply arc tangent of 1 by 4. And that's how you end up with pi, if I recall correctly. Okay. Now, I want to talk about the domain here, and this part about the range is going to get a little confusing. I want to talk about the domain. Let's go back to the unit circle. Check this out. Sine goes with y. As a matter of fact, on the unit circle, sine equals the y coordinate because it's y divided by 1. The smallest y value that I see is -1. Then the next one up on, of course, there's an infinite number of points along the circle, but for the ones that are labeled, the next one is negative square root of 3 over 2, then negative square root of 2 over 2, negative 1/2, then 0, then it's positive 1/2, positive square root of 2 over 2, positive square root of 3 over 2, up to 1. But it does not go above 1. So if I was to find the sine of any of these functions, the smallest y value it could be would be -1. If I had 3 pi over 2 or 270 or any of the coterminal ones. The largest it could be would be positive 1, which is at 90 degrees, or pi over 2 in all the coterminals. Now the reason why that is true is, remember, for all the angles of rotation, it refers to a reference angle. And that reference angle goes back to SOHCAHTOA. Opposite over hypotenuse gives me the sine. Since the opposite side is a leg and the hypotenuse is always the longest side, that cannot be bigger than that. So I'm always going to get a fraction that is less than 1. It's only when we get to angles of rotation that we deal with these weird 90 degrees and 270 degrees where I actually do get 1. But I can't make that into a triangle. And we talked about that when we talked about reference angles. So please go back and watch that. So if I reverse that, because I'm talking about the inverse function, what I put into my sine inverse sine, I have to have anything that's -1, or excuse me, between -1 and +1. Same thing with cosine. The cosine goes from 1 to -1, or from -1 to 1 if I did it the right way. The tangent inverse looks a little goofy, but remember, tangent is opposite over adjacent. So the relationship between the two legs, it can be a very, very big fraction or a very, very small fraction. So there's no restriction on that. So basically, when you see this negative infinity to infinity, please remember infinity is not a number. These are not numbers. This is just simply saying you can put any number into inverse tangent. It can be as small as you want it. It can be as big as you want it. It doesn't matter. All right? Now the range gets a little tricky. This is where it gets a little weird. And I'm sorry, I got to grab another sheet of paper here. Thought I had one, but it has something on it. Okay, so if you remember, I keep pulling back out my unit circle. If you remember, if I said, what angle has a sine of square root of 2 over 2? So here's my square root of 2 over 2. It'd be pi over 4 plus all the times I could go around to pi over 4 that are coterminal. That causes problems. If I'm doing an engineering problem, an engineering example where I have something I'm building that's in the shape of a right triangle, and I want to calculate what the angle is, then I'm going to need to know what the exact angle is going to give me. Well, what we do is we develop restrictions on what you can get back. And here's what they look like. Okay? So, for sine inverse of A, and I already know that the domain is going to be from -1 is less than A is less than +1. Okay? That's what we just talked about right here. What you're going to get back for the range, I'll draw a unit circle. If A is positive, it's going to be in quadrant 1. And theta is going to be acute. Okay, that makes perfect sense. So if I said, what's the inverse sine of 1/2? You just say 30 degrees. What's the inverse sine of square root of 2 over 2? You just say 45 degrees. So it's whatever it is from 0 up to 90 degrees and including 90 degrees. That makes perfect sense. But here's the part where it gets a little confusing. What if a is negative? Then I go this way into quadrant 4. And now the opposite of theta is going to be acute. Now the angle is going to be negative, so when I say the opposite of the angle, that's going to be a positive. All right? So the opposite of a negative angle of rotation is going to be positive, and that's going to be acute. So it's acute and acute. And here's where people are going to mess up. So if I said, what's the inverse sine of negative 1/2? I remember it's got to be in quadrant 4. I see negative 1/2, and I put on my test 11 pi over 6. And then I get it wrong, and I wonder why it's wrong. That's because 11 pi over 6 is more than 90 degrees. You had to go all the way around, way past 90 degrees, to get to 11 pi over 6. If I had inverse sine of negative 1/2, I would have to go in the negative direction and get negative 30 degrees or negative 1 pi over 6. So what I would strongly recommend is, for those of you who did draw your unit circle, make another copy with the negative angles of rotation. It would be very, very useful. Now, I'm going to do these not in order that they come. Tangent is the same thing. And of course, tangent, the negative infinity to infinity just means it can be, you can put anything in them. There's no restrictions on it. The range for the tangent, inverse tangent, is the exact same as the sine. So again, it goes in quadrant 1, where the angle is acute, if a is positive. I should have written that. So if a is positive, it goes this way, and if a is negative, it goes this way. And again, it goes to quadrant 4, where the opposite of the angle is acute. And remember, the angle is negative. So for sine and tangent inverse, if you're going to put a negative number in here, it's going to put you in quadrant 4 in the negative direction. Okay? Remember that. Cosine does something kind of weird. And again, I'll put the domain here just to be consistent. I'll put the +1. You want everything to kind of match up nice. That's great. But here's the problem. Cosine goes with the x. Well, in quadrant 1, everything's great. So the inverse cosine of square root of 3 over 2 is 30 degrees. Inverse cosine of square root of 2 over 2 is 45 degrees. That's great. Quadrant 1 works. So it looks like this, and this is quadrant 1, and this is where the angle is going to be acute. And remember, the angle is what I want. But if I tried going in quadrant 4 like I did last time, the x's are the same. So these are all positive just like these. So I can't go into quadrant 4 because I'm going to get two results for the same. I'm going to get, the two results for the same thing. So for cosine, we go half of a circle. Then we go into quadrant 2. This is where this is going to be obtuse. So if a is positive, I go here, and if a is negative, I go here. Now this is going to be helpful because this allows us in 2 more sections to use cosine to find obtuse angles, which is going to be kind of important when we get into the law of cosines. All right, so let me just quick do a couple of examples. I know this video is getting a little bit longer than I wanted it to be. So we'll just do a couple of quick examples, and I'll use my unit circle here. All right. And the direction is going to say give it in both radians and degrees, so that's not a problem. All right, so I want cosine inverse of positive 1/2. I find my unit circle. Cosine goes with the x value, so I'm looking for x's that are 1/2. And I'm only looking from 0 to pi, or 0 to 180 degrees. Since this is positive, I'm going to be in the first quadrant. Where am I going to find 1/2? Right here. Here's my x value, 1/2. So the angle that gives it to me is just 60 degrees. I'm restricted to just this domain from 0 to pi or 180. I'm not going to go all the way around 360 and come back up to it like I did in the first video. So in radians it's going to be pi over 3, and in degrees it's going to be 60 degrees. That's not two different answers. Sometimes after stressing so much about you only get one answer because it's a function, some students will ask, but you gave me two answers. I didn't. Those are the same. It's just two different ways of saying it. Okay? It's the same answer. It's just one's in radians and one's in degrees. All right, let's try sine inverse of negative square root of 2 over 2. Okay, my input is negative. That means I'm going to be in quadrant 4. Sine corresponds with the y value, so I'm looking for negative square root of 2 over 2 for the y. It's right here. So no problem. My angle is 7 pi over 4. Remember, I'm not going to go around this way to get to 7 pi over 4. I'm going to go in the negative direction, and I'm going to go to negative pi over 4. That's also known as negative 45 degrees. So make sure you don't give me that answer. What about cosine inverse of 0? And again, I hate it that they do that. So where is the x value 0 on the unit circle? So the x value here is at pi over 2 is 0, but also down here at 3 pi over 2. But remember, inverse cosine starts here, goes here 180 degrees, and it does not go further. It stops right there. So this is the only one that I'm going to include. Pi over 2, also known as 90 degrees. Finally, sine inverse of 2. So since that's positive, I'm going to go from here to here. I want to look at the y values. Where's the y value 2? Well, it looks, well, here's 1. The largest y value that I'm going to get for sine is going to be 1. So this one is undefined. You're not going to get an inverse sine of a number larger than 1 or less than -1. Okay, we'll see you in the next video.